Hi guys, in this video we are going to be discussing the cubic expressions, the cubic form of factorizing, and it's almost identical to difference of two squares, which I did talk about in my previous video in the revision of factorizing. So in the difference of two squares, which was otherwise known as dots, remember firstly this only applied to a negative. Difference means negative. And this was the standard skeleton for difference of two squares, where if you have a squared minus b squared, you'd put the a and b in a separate pair of brackets, and one bracket must contain a plus, and the other bracket must contain a minus. And basically, all difference of two squares follows this structure. It hardly varies from this structure. Just remember that if there are coefficients, those coefficients need to be square rooted as well. So this is known as in the cubic expressions. This is known as the sum and difference of two cubes. So while I said it is like difference of two squares, this applies to both the addition and the minusing of two cubes. So when you see cubes in your various algebraic expressions, your blinkers need to start going off. You need to say to yourself, hey, I think I can apply sum and difference of two cubes here. And like difference of two squares, they both have their set formulae, the set skeleton that you will be following. So let's take a look at the first one. Well, if you have a cube and we are minusing them from one another, obviously this will be a difference of two cubes. This is the resultant form when you factorize it. Now, let me go into greater detail on how we actually get this. I know this looks intimidating, but it's actually a lot easier than what it seems. Well, let's start with the first set of brackets. Remember, it always follows a binomial by a trinomial. That's the first thing we must remember. 2 terms, 3 terms. That's the first thing. It always follows this structure. Generally, we write the binomial first, but I guess it doesn't really matter. Okay, so let's look at the binomial. Well, the binomial is simply the cube roots of both of these terms. The cube root of x cubed is x. The cube root of y cubed is y. So we're just going to go ahead and put an x and a y to make up our binomial. This sign is carried over into the middle. Again, even if you look at the one down below, we copy that sign straight into there. So both forms follow the same rule for the binomial brackets. Okay, let's talk about the trinomial brackets, because that's where all the fun stuff is happening. If we look at the trinomial brackets, and again, the same rule applies to both forms, the sum and the difference of two cubes. Well, this term is essentially the square version of this. So take this number and square it, and that would be your first term in the brackets. The square, if you take x and square it, we get x squared. On the other hand, we take that term and square it, and we end up with a y squared. What's important to note is that this sign over here and this sign is always a positive. Why? Because when you square a number, it always ends up as a positive number. So it's very, very important to know that both of those numbers, the x squared and the y squareds, are always positive numbers in every single case. Okay, so we square the first term, we square the second term, and we end up with these two terms. Now we need to try and find out, how do we find this middle term? Well, all we do is take the two terms inside our binomial brackets, x and minus y, and we multiply them together. X times minus y is minus xy. That's basic algebra. And this will get shifted into this middle position, but you need to invert the symbol to the left. Okay? If we look at the example down below, which follows nearly an identical suit, we multiply these two numbers together. X times y is xy. Remember, if there's no symbol, we assume that it's positive in maths. And when I translocate it to this position, I invert this operation. So plus becomes negative, negative becomes plus. That is the only difference with the sum and difference of two cubes. Okay, let's jump straight into an example, and maybe it will become extremely clear. Well, this is clearly a difference of two cubes. 27 is a cube, 8 is a cube, x cubed, y cubed. There's cubes flying everywhere. You know, blinkers need to start going off when you see cubes like this. You need to say to yourself, hey, cubes. I know that method. And it always follows the same suit. Binomial by a trinomial. This is our binomial, that's our trinomial. To get our binomial is very easy. Well, the cube roots of 27x cubed, remember, please don't forget about the number. Don't forget about the number. The number is of the utmost importance. A lot of students would be tempted to just leave the number as is. Well, the cube root of 27x cubed will be 3x, and the cube roots of 8y cubed will be 2y. We are going to carry down that negative sign. Okay, well, 3x squared will be 9x squared. 3x all squared will be 9x squared. Don't forget about the coefficients. Don't forget about this number. So that would be 9x squared. And I'm going to do the same to this number. I'm going to do the same to that number. That would give me positive 4y squared. Remember, this number will always be positive. These two numbers in the trinomial brackets are always positive. Okay, so that takes care of that. Now to get that middle term, well, we are going to take these two numbers and multiply them by one another. 3x times negative 2y will give me negative 6xy. I am going to take this and put this into the set of brackets, 6xy, and the sign to the left will be a positive. Remember, we invert that sign. We invert it. Okay, let's do one more example on this. Again, I'm just taking these two formulae. All I'm doing is just taking these two formulae and I'm applying the skeleton rule to it. It's almost identical to dots. So clearly this is a sum or an addition of two cubes. I know it looks hectic, but at the end of the day, it is a sum of two cubes. Okay, so we're going to follow the exact same suit. Binomial by a trinomial. The cube root of 64a cubed. Well, 64 cubed, squared. The cube root of 64 is 4, and that would be an a. And the cube root of 125 is 5. X, y. And we are just going to bring that positive down. We're just going to bring that positive down. Again, we can use our calculators. If you're unsure about these numbers, you can have your calculator handy. You can have your calculator handy. So just don't forget about that, especially when it comes to tests and exams. Okay, so let's find this term and that term. Remember, they're just the squared versions of the terms in the binomials. 4a squared will be 16a squared. 4a all squared will be 16a squared. Don't forget about the number. It's very easy to write 4 here and 4 here as well. That would be incorrect. You need to square the entire term. Okay. Well, 5xy squared will give me 25x squared y squared. Positive. Okay. Now we do the same as before, where we multiply these two terms together. This will give me a positive 20axy. Therefore, I would write negative 20axy. This is the only tricky part. The only tricky part is just inverting this symbol when you put it into the set of trinomial brackets. So applying the sum and difference of two cubes is literally making use of these two formulae. You can either learn them off by heart, or you can dissect it the way that I did. Either way, if you apply these skeletons to the sum and difference of two cubes, you will not go wrong. Okay guys, thanks for watching.